My name is Cat Lutz. I work at the Jackson Laboratory, and I'm here in Boston for the World Conference. The Jackson Laboratory is a nonprofit research institution. Our connection with rare diseases are to work with families, patients, foundation, advocacy groups, to take the research that we're doing, the mouse models that we generate, and try to connect the biology, a model organism, and a patient so that we can develop therapeutics, understand diseases a little bit better, especially for rares and ultra rares where maybe some of the information is just not really well known. So in those instances, we model the patient mutation in a mouse, study the pathophysiology of the disease, and also use it as an avatar for therapeutic testing and strategies, everything from small molecules to repurposed drugs to gene editing and cutting-edge technologies. A lot of the rare diseases tend to be pediatric in nature. I'm a neuroscientist by training, so neurological pediatric diseases are a large focus, neurodevelopmental, neurodegenerative, but we don't really restrict ourselves in that sense. We're also looking at mostly rare diseases where there's an unmet need. If we can identify those areas where a diagnosis has been made, but not a lot of information is known, we have a tendency to jump in there and see what we can do. But we also work with some of the more common rare diseases. You think of spinal muscular atrophy, Duchenne muscular dystrophy, mouse models, and those disease areas are as advanced as they are because we know more about the disease and we have those good mouse models, to help us inform all aspects of research. I think it's information, it's treatment, it's resources, it's funding. When I put myself in the shoes of a parent who's just recently been diagnosed, there's this long journey of not having a diagnosis. Sometimes that's shorter, sometimes that's longer. But in the end, to have to go through that anxiety only to come out the other end and say, we don't have a treatment, we don't have a lot of options for you right now, I think just represents another mountain they have to climb, right? Another hurdle they have to cross. They need to be the caregivers, the doctors, the scientists, the drug developers, everything. And I think that all of those things are just areas where we need to push on every single one of those dominoes and say, how can we make this better? Because as it stands now, it's really unfortunate. It's hopeful in a lot of ways, but it's also a big lift, I think, for the parents and the foundations. And what we do at the Jackson Laboratory is try to ease that burden a little bit. If we can be your resident scientist, if we can be the person who can help you, inform you, make your mouse models, do the research for you, connect you with people that we know, and be more central in that role, then I think that's an incredible use of our time. I had the really distinct privilege of being involved in spinal muscular atrophy when the research and the science was relatively new. I spent probably a dozen years in working in that disease, and we learned a lot. We learned about what it takes for a disease to be successful, and it takes resources like we have at the Jackson Laboratory. So for spinal muscular atrophy, we made it a point to collect all of the mouse models for spinal muscular atrophy that were out there. We made our own. We iterated on the existing ones. We made them better. And then we thought, well, how can we now be more pipeline and process conscientious about this? And so we learned about what to do, and I think most importantly, what not to do. And that was a really good basis strategy for us because in 2016, I believe, was the FDA approved the first drug, Spinraza, for spinal muscular atrophy. And so it was really exciting for us to be, right in the mix of that, to see the mouse models that we have, look very much like spinal muscular atrophy in children. Early days of testing therapeutics and not necessarily seeing anything to get excited about, and then testing therapeutics where the mouse that was supposed to be a disease model looks just like a regular mouse and we couldn't tell the difference. So all of those things were really exciting, and it really motivated us, and as I think it did the rest of the world, to say, if we can do it for spinal muscular atrophy, why can't we do it for the rest of these genetic diseases? And then that's where the thinking comes in of, okay, well, we in some ways we have to go one by one, but we have to find the efficiencies in the groupings of these diseases and these mouse models so that we can move much more quickly. So we talked about regulatory guidelines. We talked about what it takes to get a drug to the clinic. We talked a lot about therapeutic strategies, how to more quickly advance them, but also be careful in how we move forward. I think we all agreed that nobody wants to be cavalier about these therapeutics. They have to be safe. But at the same time, we're trying to be safe and effective, but quick. Because if you think about all the different rare diseases that are out there, just even the classifications, let alone the de novo mutations that occur in individual genes, there's too many to go one by one, right? So I think collectively, as a group of scientists, society, regulators, drug developers, scientists, we have to be able to work together to see how we can do this much more efficiently, because in a lot of these cases, we know these kids just don't have a lot of time and we can't wait. The regulatory challenges are a lot, I think, sometimes. A lot of times the first thing that we look at are repurposed drugs, because they've already gone through that process. We know they're safe, we know that they can be prescribed, albeit off-label. It's so much further than we are if we start with new drug development or new therapeutic advances. It's, again, it comes down to safety, and we need to be safe, but I also think the technologies are just so disruptive at this point. We have gene editing strategies, we have gene augmentation, we have gene replacement, we have antisense oligonucleotides, we have siRNAs, we have all of these things that act at the level of the gene. And what better way to correct a genetic mutation than to go right to the source? You're not going upstream, you're not going downstream, you're addressing the deficiency of that particular gene. And while that's exciting, we just don't have a lot of data or case studies yet to say that we've done it millions and millions of times, or thousands of times, or hundreds of times. And so every time we have a patient, a need, a therapeutic, there's excitement. But then there's that overlooming question, because we don't want to do harm, to the patient. We don't want to make things worse. So it's a balance, between having to try, but not being bold, so bold that you're careless about it and cavalier. So when I think about it, we have to go in lockstep. And so a lot of the regulatory components that we think about, just need to be well thought through. They need to be careful. But we also have to be willing to understand as a community, what risks we're willing to take. I think I'm just really excited to be here, and being in a laboratory setting, working with cells and animal models and reagents is really great, and we're so happy to be contributing. But being in a meeting like this and looking around and seeing all the patient advocacy groups, such as yourself, all the people who are really sort of coming together and converging, and what I like to describe as just this tidal wave, coming at you of convergence of all of these incredible people and individuals, all really sort of tugging on the same rope and wanting to make the same changes and same differences. It's really exciting. So I'm really happy to be here and mix with the rest of the rare disease community, and I think really just come together as that community to try to make a difference.